Hello everyone. So I'm gonna start by explaining what's center of gravity. Then we'll see the difference between center of gravity and center of mass. And last thing is we're gonna see the physics behind stability of objects. We're gonna see stable and unstable objects. First of all, if we look over the picture, we know that most people would find it impossible to walk along such a very narrow beam. And we know that somehow the reason is balancing your body. What do I mean by balancing my body over the beam? In fact, the secret lies in how you are positioning your weight, where every and each particle of your body has a small gravitational force acting on it. If we join them all together, they will act as one single point or one single force pulling you at just one point, called the center of gravity or the center of mass. And we know that the weight is this arrow that pulls us down towards the center of the earth because of gravity. So the definition of center of gravity would be, it is the point where we can assume that all the forces acting on the object is concentrated. So it's the point at which the whole weight of the body acts, and it's an arrow pointing always downwards. So what's the difference between center of gravity then and the center of mass? As a definition, center of gravity is the point where gravity appears to act, and center of mass is the point where the whole the whole mass is concentrated. Okay? Well, since we live on Earth, and we know that on Earth we have a uniform gravitational field, it's considered as constant, it's considered as 10 or 9.8, then we can assume that center of gravity and center of mass are pretty much the same. But if you send a spaceship to space where gravitational field force is not constant, it's not uniform, then we cannot assume that center of gravity and center of mass are the same. Okay? So how can we find the center of mass or the center of gravity of objects? It all depends on the shape of the object. If we're dealing with regular shapes like these one, then it's enough to just trace the symmetry line of the object, and then the intersection point represent the center of gravity, and you represent the force acting on the whole object as an arrow pointing downwards. Same thing happens here. It's the symmetry line, and their intersection point represents the arrow, and their intersection point represents the arrow, and last one, this represents. If we look over these pictures, we can see that the center of gravity is a point that lies inside the object. It's within the object. As for this one, center of gravity seems to be outside, and it's fine, it's totally fine. So center of gravity is this point that it can be inside the object or it can be outside the object, where the whole forces acting on the whole object are concentrated, and they act as a single point pulling it down. Okay? Now, what if we had an irregular shapes? Irregular shapes, in order to find the center of gravity for irregular shapes, then we have to do an investigation, and this will be your task, a criterion B, to plan an investigation to find the center of gravity of irregular lamina. Now, we know that different objects have different center of mass. So how does this relate to how stable objects are? If we look over the first two pictures, we can see that in the first one, the person is standing on only one foot, and still the person is balanced. But he will be even more balanced if he was standing on both feet. This is because if we compare the base in both pictures, we can see that the wider the base, the more stable the object is. As for the last one, the base, when he was standing with both feet away from each other, he is even more stable. So the first factor that affects, factor 1, that affects how stable an object is the base. Okay, as we can see, a wider base can make an object more stable. But why? We will see this in factor 2. If we have a box where we already know where the center of mass is, or the center of gravity, and this arrow, the red arrow, represents the force downward pulling on the box, we know that this box is stable. If we tilt the box with a specific angle, it will remain stable. It's still stable. Okay? Now, tilt it even more, and then suddenly the box is balanced. If we tilt it even more with the steepest angle, we can see that the object topples over. So what's the secret between all of these 4 pictures? What's the difference between them? If we compare the base in each one and where the center of gravity is lying, we can see that in these 2 pictures, the arrow representing center of the weight pulling down, it lies within the base. So it's still within the base. Okay? Same thing here, still within the base. As for this picture where it balanced, we can see that the weight arrow is at the last point, or like the edge of the base. And what happens here when it topples over? We can see that the arrow is no longer falling within the base. Okay? So this is why it is important to have a very wide base. The wider the base, the more stable an object is. Okay. Now, did you ever wonder how was the double-decker bus designed and what's the physics behind it? In fact, the double-decker buses, they undergo many tests to ensure safety and stability on the road. And one of the tests is tilting test. This is because the stability test is to make sure that the bus, once it's driving at a very high speed or at a high speed, and it goes, let's say, to a roundabout or a very sharp turn, it won't tilt over, it won't topple. Okay, so this picture shows the real test. So what's the physics behind this? If we mark where the edge is, or the point, the pivot, this is the pivot, okay? So we're tilting it about this pivot, this point, and if I draw the base, that's the base of the bus. Okay, and now for the arrow, this is the arrow representing what? The gravity. Okay, the weight, the force of gravity pulling on the bus. As you can see in this picture, first one, the angle is not very steep, so this angle is not very steep. The bus is still stable. Why? Because the arrow is still lying within the base, so it doesn't topple over. While in this picture, since the weight, it doesn't fall within the arrow, it's on the last point, it's aligned with the pivot, then it's at a very high risk to topple over. Okay? This is why people that are sitting up, they should not stand at any time, because if they stand, then the center of gravity will become higher, so it will become somewhere, let's say here. And if I draw now the arrow, you can see how the arrow is now completely outside the base, and so the bus will for sure topple over. Okay, so standing up, having people in the bus standing up will make the center of gravity higher. And this is the reason why sport cars are designed with a low center of gravity and a very wide base. Same thing with other cars, and you can see how cars nowadays are being designed to be more secure and more stable. So what are the things that increase the stability of object? First thing, we just said that the wider the base, the more stable an object is. And so what's the second factor? If the person is squatting, if he squats, then he's lowering the center of mass. So he's lowering his center of mass. As you can see, the center of mass now is lower. And so this position is the most stable position between all four. So the two factors are: 1, a wider base; 2, a low center of mass. And this is the difference between stable objects and unstable objects. So now we know the secret behind why the Leaning Tower of Pisa doesn't topple over. It's because if this is the base, the center of mass is low enough, somewhere here, in a way that if we draw the arrow representing the weight, yes, it still lies within the base, and this is why the Pisa Tower doesn't topple over. Okay? I hope this was helpful, and take care.